Hey guys, welcome to day one of solving Leetcode daily challenges. So today's problem is find first palindromic string in the array. The problem states that given an array of string words, return the first palindromic string in an array. If there exists no such string, return an empty string. So let's see what is a palindrome. A string is a palindrome if it reads the same forward and backward. Let's check some examples. So let's see words array is given which consist of some set of strings. Okay, so ABC. The let's check if it's a palindrome or not. If you reverse a string, it becomes CAB. So this is not a palindrome. And CAR, it becomes RAC, which is not a palindrome either. And let's check ADA. So the reverse of the string becomes ADA or again. So as the reversed and original string are equal, we can say that they are palindromes. And let's check if race car is a palindrome or not. So race car becomes RACECAR. That is in reverse. Let's say, so what is RACECAR? So we can see that RACECAR. So the both strings in original and reverse order are equal. So it is also a palindrome. Let's see, check if cool is a palindrome or not. So LOOC will be the reverse format, reverse string of the cool. So it's not a palindrome. The problem states that we have to return the first palindromic string. So we can see that ADA and race car are palindromes, but first ADA is encountered, so we return ADA. Let's move to the coding part first. We'll just return a simple is palindrome function. That is boolean function like is palindrome is of s. We'll just return s equals to s of reverse. So it returns true or false. That is if the given string is palindrome or not. Let's check for every string in the words. Like for I in words, if is palindrome of I is true, we'll just return I. So if no such palindrome is found in the words array, we'll just return an empty array. Let's check if it runs fine. Yeah, the code runs fine. Let's submit it. Yeah, nice. So let's do an let's see the time complexities. So for I in words, the loop runs for um n times, that is length of words times, and here is palindrome runs for length of string times. Let's say m equals to length of s and n equals to length of words. Yeah. So here the time complexity will be order of n cross m, as the words array runs for n times, that is length of word times, and each time the length of words will run for each palindrome, that is each palindrome runs for m times, that is length of the string in the worst case. But in the we can see that if the first string in the array is palindrome, then we can just say it's best case, and the loop runs only for one time. That is, we can say in the best case, the time complexity will be best case time complexity will be like order of n times, that is length of the string times. So here the space complexity can will be big O of m. So in order to reduce the space complexity, we'll take a two pointer approach, which is an optimal one for this. Let's see how to do. Yeah, let's take an two pointer approach, a b c, okay, b and a. We'll take two pointers for at first index, that is 0 1 2 3 and 4, and lost index at fourth lost, I mean alert lost index. We'll just compare both the characters. As we can see, a and a are equal. We'll just return like we'll increment the f value here and L value will decrement it. Okay, we'll just compare both the characters. We can see that B and B are equal, and we'll just increment F and decrement L. We can see that F and L points to one single index, and we can say if they both are at same index, we'll just return true. What if this condition fails? Like we need to find a which string is not a palindrome. So A, B, C. Let's take E and A. Okay, in this case, we can just take F at first index and L at last index. We'll just compare both the characters of S of L, L and S of F. So we can see that A and A are equal. So we'll just move the index to next part, that is F to F at the index of B and L at the index of -1. So we can see that B and E are not equal. As soon as we can see that both the index are not equal, we'll just return false. If in this case we can find out that if given string is a palindrome or not. So let's move to the code part. Yeah. Let's take first index and last index as 0 and length of s -1. And while f is less than or equal to last index, we'll just compare if s of f is not equal to s of l. That means the characters are not equal, we'll just return false. And if this condition is not encountered, let's say if the both characters are equal, we'll just increment the f value by 1 and decrement the l value by 1. And if we say the whole loop is executed and let's say f is greater than L, or when it is equals to L, we'll just come out of the loop and return true. And let's check if the code runs fine. Yeah, the code runs fine. Let's submit it. Yeah, it runs fine. Let's see what is the time complexity for this. The time complexity will be big of n cross m itself, as we run across the length of the words, and the palindromic string runs across the whole string in the worst condition. Like um, if the string is a palindrome, then the string should run across whole length of the string. So the space complexity will be decreased. That is, space complexity in this case will be big of 1. That is, we are not storing any kind of reverse string, so the space complexity is reduced and it becomes 1. So that is it for today, guys.